Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on January 29th, 2026, about 3 days ago. It finds that reasoning models like GPT-5 and Claude Sonnet 4.5 can surprisingly predict program termination, achieving performance levels that would rank them second and third in the prestigious SVComp 2025 competition. The paper is titled LLMs versus the Halting Problem, Revisiting Program Termination Prediction. And as we'll see later, these findings suggest that general-purpose models are becoming competitive with highly specialized verification tools for complex semantic tasks. Figure 1 illustrates this contrast between traditional engineering and the new generative approach. On the left, we see the architecture of Proton, which is a state-of-the-art verification tool. It relies on a complex, multi-stage pipeline involving instrumentation and symbolic execution to analyze code. In the center, there's a simple input-C program with a loop that eventually halts. Then, on the right, the figure depicts the LLM method, where the model simply ingests that raw code and directly outputs a termination verdict, completely bypassing those specialized intermediate components. So, while Figure 1 showed a simple terminating case, Figure 2 illustrates the harder challenge, non-termination. Here, the C code example at the top contains a loop that can run forever if the variable I hits 0. When the large language model predicts this outcome, it isn't enough to just output a label. Instead, the middle section shows that the model must generate a witness automaton, essentially a graph proving the infinite loop exists. Finally, this proof is sent to uAutomizer at the bottom, which validates whether the proposed cycle is actually feasible. Alright, having established the validation method, Figure 3 reveals the final leaderboard using SVComp scores. The gold standard is still the specialized tool Proton on the far right, which leads the pack with over 3,600 points. However, notice how the proprietary models in gray, specifically GPT-5 and Claude Sonnet 4.5, follow immediately after, effectively taking silver and bronze. Interestingly, the blue bars for open weights models, like CodeWorld Model and QN3, show that test timescaling, indicated by the dotted texture, provides a massive boost, transforming their performance from mediocre to competitive. Well, to understand those leaderboard totals, Table 1 details the asymmetric scoring system used by the competition. Notice that while correct predictions earn only small rewards, like 2 points for termination or 1 for a valid witness, errors are devastating. Specifically, the bottom section shows that incorrect termination predictions trigger a massive penalty of minus 32 points. This heavy cost for mistakes explains why the 0-point unknown category in the middle is so important. It offers a safe harbor when the model is not certain. Okay, since the previous table established that witnesses are required for points, Table 3 now reveals just how hard it is to generate them. This table tracks the success rates for producing valid witness automata, which are formal proofs of non-termination. Notice the top 2 rows for GPT-5 and Claude Sonnet 4.5. Even these leading models only achieve validity scores around 41%. That implies that for the majority of non-terminating programs, they can guess the correct verdict but fail to construct a valid proof. The situation is even tougher for the remaining models like CodeWorld Model and GPT-4o, where validity drops to between 25 and 30%. So, while Table 3 highlighted the struggle with formal proofs, Figure 4 reveals how code length impacts performance. Here, the programs are grouped into short, medium, and long categories along the horizontal axis. The chart shows a clear downward trend, where longer code generally leads to lower scores. The blue and orange lines at the top indicate that GPT-5 and Claude Sonnet 4.5 are the most robust, staying positive even on long inputs. Conversely, the red line for QN3 crashes deep into negative territory, likely due to severe penalties. Interestingly, the purple line for GPT-4o remains flat and low because it frequently predicts unknown to avoid making fatal errors. Wrapping up, 2 takeaways stand out. General-purpose models now rival specialized tools on undecidable tasks, like the halting problem, yet they still struggle to generate formal proofs. This suggests the future of verification likely lies in hybrid neurosymbolic systems that combine intuition with rigor. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.